And please welcome to this final panel, Monika Kuffer from the University of Twente. Monika's work focuses on mapping informal settlements and urban inequality using satellite imagery, helping make visible communities that often don't appear in official statistics. Does that sound somewhat like you? Oh, very good. Please turn your microphones on. That's the small button up. Yes. When it turns green, you're back on and takes a... And then Lina Eklund from Lund University, who uses satellite imagery to study environmental change and conflict in the Middle East. Her work shows how landscapes and political realities can be observed from space. So you're very busy, right, these days? Leif Haglund from Maxar, one of the world's leading commercial satellite imagery providers. Maxar's satellites capture some of the highest resolution images of the planet. We're going to talk about 3D, possibly 4D, maybe, the kind of that researchers increasingly rely on.
Except that Maxar has changed name and is now Vantor.
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 Yes. That's right. And Stefanos Georganos from Karlstad University, who works on machine learning and geospatial analytics, developing new ways to extract social insights from massive Earth observation datasets. Sounds pretty right?
Sounds about right.
Thank you so much. So great to have you here. I'm going to take a chair because I don't want to be standing. Let's see if that works, yes. And if I don't fall off the stage. Yes, it's okay. Thank you. Great to have you here. What are your? I mean, just a quick question from the day so far. What are your observations? What are your thoughts? What's Lina?
My thoughts. I want to answer like Ola. There's hope.
There's hope.
There's a lot of interest in these topics, and that makes me happy.
Yeah. Any other thoughts about today so far?
I think it's important to bring communities together.
Yeah.
Because I think we are still working too much in silos. And if we move together as cross-disciplinary groups, I think we can advance science.
So Earth observation is evolving rapidly, higher resolution satellites, more frequent observations, AI-driven analysis. So from your perspective, what is the single most important technological shift that will shape satellite-enabled social science over the next decade? Joris, do you want to start?
Absolutely. That's a very nice question. Well, right now, I believe the state of the art is around this so-called geofoundational models, right? So we're talking about extremely large models that are fed basically millions of images, which then can be used for a lot of different applications, such as mapping built-up areas, vegetation parameters and indicators. If we want to move a step further, we need to definitely integrate other types of data within these models. We're talking about, let's say, migration data, mobile data, flows, any sort of socioeconomic data, so what we can make, I would say, reasonable estimates of more complex phenomena, because we're moving from a dimension which maps the physical representation of a pixel. Is it a building? Is it a settlement? To giving it, I would say, more deeper layers, more abstract layers that could refer to vulnerability, to social concepts. And for that, we would need to think about data fusion and also definitely bringing in different disciplines, because this is not an easy task, and I would not want to let it at the hand of computer vision scientists only.
Data fusion is one piece. Monika?
Data fusion?
No, sorry. The question is the same. Sorry, I'm just...
No, I think it's... I think one challenge I think I'm very much attached to is to bring data to where it matters. Because let's say most of the people here in the room are scientists. And we really need to bring the data in the hand of users and need to understand what kind of information needs they have. And I think that's still insufficiently done. from our sides. Similar to a question about how do we communicate uncertainties with users, because often users don't understand our very complicated F1 scores they cannot associate with. So how useful is this map to me? And that's something we really need to bridge besides many technical challenges to make data really operational, actionable, bring it in the hand where it matters to decision makers, and hoping for decision made on evidences and not on all kinds of weird narratives nowadays.
Or gut feelings.
Yes.
Leif,
Yeah. Two things then.
two things.
Short ones. I
Oh, well, you don't need to be short.
Higher spatiotemporal sampling rate will be high resolution both in the room and in time, will enable a lot of new application, and it will also make current applications more with less uncertainty. And the second thing is that the globe here, at least the part that humans are living in, is definitely 3D. So I think reasoning in 3D will be really important.
So reasoning in 3D.
Yes.
Okay.
So a building is not a flat building seen from upside. It's actually a three-dimensional building. How high is it? How can you reason around that? That's another. It's not another feature. It's another dimension to the data.
Okay. So adding dimensions would be an important technological shift. Then, Lina.
So I'm going to say diversity of satellites and sensors, because maybe there's no single one.
Doesn't have to be.
Yeah.
All right.
So
although the question was the single most, but
yeah,
sure.
single most. But I'm going to say diversity with different types of sensors, like synthetic aperture radar at different resolutions, thermal, hyperspectral, and general high resolution, very high resolution data will be very useful.
Yeah, so the short answer is, cloud enabled, and, these notebooks that are making it so much easier to integrate data from different areas. And there are some barriers, like if your data are in two different clouds, it can create a lot of issues. And so those are some technical issues. I just want to go back to like an example that I think social scientists, for one, they are a little bit leery of all this gee whiz technology, but the other, and there are increasing numbers of computational social scientists. So things are changing, and that's all to the good. But I do think a critical view of some of these data is also really important. So just a short anecdote, I worked at IUCN back in the late 90s in the social policy unit. And our role was as social scientists to work with the conservation biologists to better design interventions. And I remember when I first got to Columbia after working at IUCN, I said to a colleague, hey, wouldn't it be great if we took these, what they call community conservation areas, and applied remote sensing to identify whether they're actually effective, because they were being proposed as incredibly important mechanisms to reduce deforestation around protected areas. And the response from one of my social science colleagues was they didn't want to do this. Maybe it was like, we don't care what the evidence says, we just want to propose this. But there's also a sense in which just measuring, like deforestation is not a trivial thing to measure, even though it seems like, oh, this was forested before. I mean, I've done some work around mangroves and other things. It's incredibly difficult to figure out, like, is a pixel, especially at a 30-meter resolution, which was generally the resolution at that time, was forested or not. So, then we get into a situation where we really have to be careful. It's a bit this uncertainty question, and understand also the grounded realities of people who are working with these communities. And so the success rate just measured through remote sensing may not be the best metric to say whether or not a community conserved area is actually working or not.
So I'm hearing a couple of different things, but so will the main transformation come from better satellites or better algorithms or better data integration? I could hear somewhat that what you were already talking about, but is there one or the other? Lina, you already talked about three things. Could you narrow it down, or no?
No,
Sorry.
I think that's really hard to say. Maybe some other have better ideas.
We don't have to narrow it down if we don't want to. So, what are the main advantages? So, and the possibly the biggest limitations of using satellite imagery in your area of research, Stefanos?
Yeah, I mean, in my area of research, remote sensing is absolutely necessary, given that we work in data-scarce contexts, right? So we have very limited information, and often it is a very powerful resource to do meaningful work. I can bring an example of, I was I was studying, case study was Ouagadougou in Burkina Faso, and we were trying to create, to find the blocks of the city, the street blocks, and we couldn't find them anywhere. We weren't sure if they even existed in a database. So we used a very high resolution image, could be from Maxar, I have to double check.
Probably.
to automatize a process where street blocks were delineated, the land cover was mapped, and then from the land cover we went to the land use, right? So very necessary tools for urban planners at the time to be able to use, and of course the dataset was public, and we were very happy with our approach. Now I think in Sweden, for example, we have the opposite. We have too much data, so it's a very
Too much data.
It's a very data-rich context, right? So we have to be smart, I think, and very creative on how to integrate the remote sensing component there. I think there is endless opportunities, but I think that's what we will be trying to do also in the next years, to figure out how to do that properly.
Alex, I think that was also what part of your keynote, to how to integrate data in a better way. So I'm assuming you're only seeing advantages in satellite imagery.
Yeah, I mean, the volume of data is just exponentially growing all the time. You've got these small sats and other things that are constantly sensing the planet. So I think our ability to sense is exceeding our ability to make out of what's happening on the planet, as illustrated by Andrew's earlier presentation, right?
Yeah.
It's very difficult to synthesize all of this, but yeah, there's an abundance.
So trying to synthesize all the data and trying to figure out if there's too much data or just Monika.
I think there are many places where there is not much data, and maybe taking two examples. One is I'm working a lot with local communities on the ground, and we are trying to support their legal claims on land rights. So one recent case was Makoko in Lagos. It's a fishing community built in the lagoon of Lagos. 100,000 of people living there. They have been recently evicted, large parts of it, with very dubious reasons behind. So we were asked by our counterparts, can you please make a map showing the extent and the sort of the stepwise evictions, because they have been bulldozed even within, like, not noticing people. So people were running to their houses to grab things while the bulldozers were active. Unfortunately, Lagos is a tropical area, so we were waiting for 3 weeks, no image without clouds. So radar is a solution indeed. So that's, but it's not as, if you want to make and we use this in court cases, or our partners are using the maps we're producing in court cases. So radar is a bit complex for technical people to understand. So there's still, let's say, too much data, yes, no, but often we don't have the data where we really need the data. Another example is a place, I don't know if anybody in the room had heard about a city called Nyala in Sudan. It was a place which was inhabited by about 1 million people. It's in Darfur zone, and this place last year was basically, like, the city is still there. The structures are there. If you look into Maxar images, you see that large roofs are gone. And what is gone is the light and the air pollution. And basically, I'm working with colleagues from UN Habitat Sudan. The people left. So 1 million people somewhere left. it's a sort of ghost city by now. But we have hardly any information from this zone because there are no journalists. A few narratives who are coming from these places are horrifying, but there's nobody on the ground to produce evidences, and there remote sensing can fill at least some gap, seeing what is happening on the ground. But often access then for like NGOs, etc., to high-resolution images is still a big challenge. And sorry, just to make clear, like high-resolution images come with high costs. So we are talking about roughly about 20 euros per square kilometer of a Maxar image. For a city like Nairobi, it's about 20,000 euros to cover the whole city. So it's high-cost images to get access to.
Leif?
Sorry.
It's perfectly fine. The basic is that the satellites are extremely expensive.
Yeah, no, yeah.
So it's I don't know, the old ones.
We're not questioning your business model. That's not what we're doing.
Well, I do myself sometimes. So it's not that, but it's 600 million to 700 million dollars in space for the old ones, and maybe $250 million for the newer ones. So it's a lot of money that needs to be somehow paid off for. I'm not sure that you should do it with university money, but maybe the World Bank can have some money, and then you can always negotiate the price. But I do agree, and I think that's an extremely important thing for Earth observation, is that it's transparency, that you can actually see what's happening. You don't have to trust politicians saying what happens. And it has been a lot of times in Ukraine that it has been obvious that the Russian version is not the right one. And I think that transparency is extremely important.
Lina, main advantages.
Main advantages.
Yeah.
Well, I really like to be able to go back in time travel. So when I look at an area that I'm interested in, I want to know what has happened a long time ago, not just what's happening now or in the past few years.
And when you're saying a long time ago, what do you mean?
I mean, as long time ago as possible, which is, I mean, it's of course limited. So with Landsat, for example, you can go back to the 70s if you're in an area where there's images that were collected in the 70s, but like 80s, early 80s usually. And that, I mean, that allows you to see what kind of changes are happening in the area with settlements and with land cover, so that you can see, well, I mean, for me, I'm looking at conflict areas. So if I see a change, not every change is related to conflict. They can be normal changes that happen. So having this long-term context is really important.
So we were talking a little bit about data fusion. So the future of social science analytics may lie in data fusion. I say may, I'm not sure. Combining satellite imagery with mobile phone data or social media or IoT centers. What are the hardest technical challenges in aligning these data sets across space and time and scale? Anyone?
So what did you say? Cartography, geomatics. No, but that's a challenge, of course. Where is it in time and space?
Yeah.
I think, just to comment, I don't know if it's an answer to this, but having a really data-rich environment like in Sweden, that's a possibility for machine learning as well, to use that as a training data. So, so you can infer that to other data poor things. So I don't think I answered your question at all, but I think that's a comment that I would like.
People rarely do, so that's fine.
I think that's a way to go forward.
So, Alex, you've worked extensively on climate vulnerability mapping and integrating satellite and socio-economic data sets. What are the most promising ways of combining Earth observations with demographic and socio-economic data to understand climate migration, human vulnerability?
So a lot of our work is done using fairly simple models and not necessarily heavy in, machine learning and other things. And that's partly, a belief that you get maybe more transparent results as a result of doing it that way. I'm not saying that they're perfect. They have their own limitations. There's not a lot of constraint for doing that, and I just think it takes some knowledge of the data that are available and what can be done, and perhaps also what should be done. There's ethical issues as well about, I often think that, in our blithely presenting data on climate risk and vulnerability in some parts of the world, well, that could be a strong signal to a market investor not to invest in that particular area. These countries in the global south in particular are already disadvantaged, right? Their credit ratings are often very poor, so that means they don't have access to global capital in the same way that Sweden does. And so I think we have to be conscious of that as well. And just because we can do something doesn't mean that we necessarily should. I learned the hard way when we did the climate mobility mapping, so this projection of future climate migration, which was all internal to countries. So we weren't looking at international migration, but immediately was picked up by the Hungarian government, what's the head of state, and used as an example of like another threat that's going to be looming for Europe, right? More migrants, pushed by climate change, the disenfranchised, the hapless migrant who shows up on your shores, and it becomes a whole narrative that's very hard to get out of. So these are some issues that arise.
Stefanos, you work at the intersection of machine learning and Earth observation analytics. What technical breakthroughs or in AI or geospatial computing do you think will most accelerate satellite-enabled social science?
Yes, I think we basically go back to your first question, like the breakthroughs, and I think we're talking about very large models that are trained on millions of images, and they will be also accompanied with ancillary data related to, I would say, more human attributes. But this has to be done very cautiously. If it's done recklessly, it would be kind of what Alex just said. Just because you can do something doesn't mean that you should do something. I know, for example, Google has already is experimenting with microcensus models that are combining all of this information, and we have to make sure that it's done in the right way, right? So we need to definitely establish the bridge between social sciences, technical sciences, and definitely bring up the topic of geoethics on that, which is becoming much more important every year that passes.
And Leif, how do you think commercial Earth observation, very high resolution imagery, near real-time monitoring will change the possibilities for research and policy analysis?
Well, there is a balance, of course, between commercial imagery and putting tax money on sort of governmental satellites, where the user of the data don't really pay for it, like Sentinel data or Copernicus data. You don't pay for using it, but of course there has been a tax pay on by that. Where should the tax money go? Should it go to the university or the institution before that? So there is a balance that not really has been discussed fully, I would say. I understand fully that sort of it's expensive to use commercial data, and hopefully the price will go down. And, so
I think they agree. It seems like Monika, you've done pioneering work on mapping informal settlements, urban inequality using satellite imagery. You gave 2 examples earlier on this. What are the technical challenges in detecting and monitoring informal settlements from space?
If I may violate your question.
Yes, please.
It's like there are many technical challenges, but there's also a lot of development. So there are a lot of development in models. I would say the most technical related challenges is not we are not further developing more advanced AI models, but data quality aspects. because we often, and that's particularly an issue in mapping informality, because if you go even to a city, stakeholders often don't agree what are the boundaries of informal areas, because it's so complex to define. Then most of the global models, so there are a lot of research now developing global models, which is very much a push, for example, from UN Habitat, because they want to have a base for SDG monitoring. They know the existing SDG indicator is, I shouldn't say this public, but is very doubtable. Like this 1.1 billion people, it's a big question. Are this 1.1 or is this 2 billion people? Nobody knows. So we really need Earth observation to bring some more light on this, extend the location, the geography, etc. But we continue to train our models with data which are mainly curated in research labs by people digitizing boundaries and then training with boundaries which have no clue and no local context. So we are building data which are not grounded. And the investment in data quality, and that's of course a huge investment, people are shying away from it. And I think that's the biggest challenge of bringing data, but also understanding the temporality, going back to, and that's again relating to my legal case, often you need to show that the past of a settlement, that people get land rights, that they can rebuild their existence, because that's one of the biggest challenges for people on the ground. They don't have their rights, so they can be kicked out any day from this place. And there are a lot of cool data sets which actually we are not using, and also which might be disappearing, like I don't know if people know the Corona data sets. It's declassified US spy images, which are going back even further than the 70s, which can show the historic involvement of places. So we should use a lot of the,
Did I hear you right? Did you say spy images?
Yeah, declassified US spy images. Investment in data, I think that's my main point.
So Lina, your research uses satellite imagery to study conflict, environmental change, land use in fragile regions. What kind of social and political dynamics become visible through satellite data and that would otherwise remain hidden, possibly?
So I have a good example of that, and it's an example that I use with my students and even have written an article about, where if you go to Google Earth and you look at the border between Syria and Turkey, and it's just a regular, true color image, and you can see, even if you remove all the borders and the labels and everything, you can still see where the border is, because on the north side of the border, on the Turkish side, everything is quite green, lots of vegetation. On the south side of the border, it's more brownish. It's as if someone has sort of started erasing the area. If you are on the border, it's likely that it will rain more or less the same amount, just a bit north of the border and a bit south of the border. So this is not something that's biophysical. It's actually a matter of politics and resource management and upstream versus downstream hydropolitics. And I think that's a really interesting example of that you can show with satellite images, like the inequality in terms of water access and resources for agriculture.
So I'm gonna wrap this panel up already. Yes, you look very surprised, Alex. I know we can sit here all day, but we also need to go to the Grand Hotel and have a beer. So if we meet again, let's say in 10 years, that's a long time in terms of what's happening, and it should be in a year or so, but let's say 10 years. What would you hope satellite-enabled social science can do that we cannot do today? 10 years, that's a long time. Monika, you want to start?
So my grand vision is to have very simple web-based tools that anybody can run a model by himself.
So web-based tools, that would be great. Stefanos?
A set of actionable data that social scientists, stakeholders, businesses, they can work with directly, but are self-representing themselves without too much technical knowledge.
Actionable data, all right. Leif?
Yeah, access to 3D data then.
And cheaper data.
Global 3D data.
Yeah, Lina.
I'll say also what they said, but I also would like to see Earth observation being used more for accountability in war crimes and human rights violations.
I think training is important in the social science communities, so in spatial approaches, and not just in the global north, but also in the global south, and enabling a broader application of these tools in more settings.
All right. Thank you so much for participating in this panel, being here. Give them a warm hand. Thank you so much. So.